We have product managers who in the past would have to work with design for 2 weeks to get to prototypes. Now they're going and vibe coding this stuff with the complete understanding that this is not going to go production, but it's going to be a really good example of this is what I'm thinking. Here, I have proven that it's technically possible. And now we don't need to go through that back and forth review stage.
The traditional sales cycle, product managers brief, designers create, and then engineers estimate. Code gets written. But now, a product manager with V0 or Replit or Lovable can build a prototype after a kickoff meeting. Claude can write and deploy a feature in a few hours. But here's the question. Is it one for one? What are the trade-offs? Ultimately, does it work? Because when features appear faster than you can document them, you need new ways to validate what's real and what's reliable and what's ultimately going to break in production.
Number one, how do you actually track and test this? How do you observe this? And number two, almost more important, because LLM ops is an extension of ML ops, which has existed for a long time. And there are ways you can test these outputs. Evals, that's the biggest calling card, I think, in the entire industry. Evaluate your outcomes, test at scale, understand that this change has impacted this other piece of your system because it's so interconnected. But where it becomes very difficult is how do you take an entire workforce and upskill them in AI? Very possible, but also have them kind of break the way they've always approached software and think differently and think in this new non-deterministic way where it's almost an art as it is a science, and really get into that art and get into that science and lean into it as opposed to freaking out because this is not the way it's been done in the past. Then when we get engineers in the same room with product and design, with AI enabled tooling, the efficiency is absurd because everybody's already using this in their day to day. And we see them using this and collaborating, using AI as kind of this jet fuel already on top of this engine that's moving very rapidly because of AI. And it's very impressive. It's something that you would never have expected to happen 5 years ago. People can build a lot quicker, but if they aren't mindful, you can end up with software that is more messy than if you coded it by hand. Not testable, 80% complete, not 100% complete. So it's a very big like quality review, understanding that people are using AI, embracing that because you can be more effective if you have a very talented engineer, which luckily all the people at Automattic are talented, using this because they already know how software works. They already know where to steer this stuff.
Automattic literally wrote the book on remote work. 20 years of distributed teams, 1,500 employees across 90 countries. They proved you could build something that powers 43% of the internet without sharing an office. But AI has impacted that model too. When experiments cascade into experiments, when 3 people can build what used to take 30, async communication struggles to keep up. So the champion of remote work did something new. They opened an office.
It's a place where we want to do an experiment of what happens when we have people come in every day or every 4 days a week or 3 days a week and sit together and think about the biggest problems in open web, in AI, and all of this stuff. What comes of that, especially with this remote company, like we were talking about before, with all of these resources, all of this talent, the massive scale. How can this in-person group maybe almost operate like a startup within Automattic? That's an issue, especially on the engineering side, that everybody has, right? It's something where in black and white, AI LLMs are non-deterministic. And it gets even more compounded when you're like, all right, I'm going to let one LLM run a collection of a bunch of other LLMs with tool calls, and we'll call it a multi-agent system. And there are like many layers and it does all these crazy things. And like sometimes it works very well. But as engineers building this stuff, we have engineers going from, I have written 30 lines of code and now I have this new feature and I know exactly how it works and I know exactly how to test it too. I have this 30 lines of code wrapping a bunch of natural language, contributing to a more global system that orchestrates this natural language. They know when to stop using AI and start using the hand coding. This doesn't work. I know this doesn't work because I know my software, so I have to build it myself. And that's an organizational change and a big thing that management needs to enable and be mindful of. We're doing a good job of it. We're making sure that managers are working with their engineering leads, are working with their groups to say, here's how best we can use AI. Here's when we shouldn't. So you have to invest into the fact that you will use AI, but you also have to understand that your products are durable products that need to exist in 10 years, not something that I get a feature now, but I blow up the product in 2 years.
James focuses on the challenge at the heart of synchronous development. We can build anything in minutes, but knowing what will last takes years of experience. As code becomes cheaper, it's tempting to value it less. But this can't translate to products, to stability, to longevity. Think like Automattic. With 43% of the internet depending on your code, they can't afford to mistake speed for value.